Alrighty, let's take the derivative of this. Now be careful, this is a chain. This is like a multiple chain. You'll see the outside piece is 3 to some power. Inside of that is a something squared. Inside the power is something squared, and inside of that something squared is the cosecant x. So the outer is 3 to some power. Inside of that is something squared. Inside of that something is a cosecant squared. So let's take the derivative of the outside piece. So the derivative of 3 to some power is just going to be 3 to some power times the natural log of 3. That is the derivative of 3 to some power. Now what we're going to do is we're going to leave the power, so that's going to be something. So we have a squared there, and then inside of that is going to be cosecant x. So now our goal is to take the derivative of this piece. We're going to take the derivative of that piece, which the outside piece of that is the 2 to some power. So 2 to some power leave us that. And we leave the inside, so we leave the cosecant x. One more time, just leave it. Now we take the derivative of the cosecant x and we tack it on the end. So we're now going to take the derivative of cosecant x. The derivative of cosecant x is negative cotangent squared x. And so we have just simplified all of that. Now I do want to clean it up though. So let me clean it up some. So my final answer here, in my opinion, I'm going to put the negative 2 in front, and I'm going to put the ln 3. Okay. I'm going to also now put the cotangent squared x, and I'm going to put the cosecant x, and I'm going to put the power last. So the last one's going to be 3 to the power of cosecant squared x. So that would be a cleaned up derivative of this. Let's try this one now. So for this next one, the outer piece, hopefully you see, is ln of something. Inside of that is 5e to some power, and the power actually inside of that is 2 minus x. All right, so we're going to take the derivative of ln blank. That derivative is going to be 1 over blank, or the derivative of what's inside. All right, and the inside is just going to be, 1 over the value of what's inside. So that's 1 over 5e to the blank with the 2 minus x. So again, the derivative of ln blank is 1 over what's inside, and what's inside is this. So I'm leaving that on the bottom. Now my goal is to take the derivative of this, and this is going to be another chain. So you're going to need another chain here. So as I take a derivative of the bottom, that's going to be 5e to the blank, because the derivative of 5e to the blank is 5e to the blank. It's just kind of nice like that. We leave the 2 minus x, and then the last step is to take the derivative of what's on the inside. So the inside of 2 minus x, that would just be negative 1. So if we multiply that all together, we will end up with negative 5e to the 2 minus x on top with 5e to the 2 minus x on bottom. And if you think about that, won't this and this cancel, leaving you simply negative 1? So what's interesting is this function has a slope of negative 1 always. It's a line. That's really interesting.